see I'm already advancing from paper to digital. We are talking about physical, but I'm transferring to digital. It's a great honor to be today with you as a Chief Sales Officer of ORQA, and in behalf of our CEO, I promise I'm not going to try to sell you drones. I'm going to try to do that in a follow-up email. It is a privilege, as I said, and the theme of this session, autonomous applications powering industries, is deceptively optimistic. Let me tell you why. It suggests that autonomous applications already exist, which we can maybe agree to some point, but also that the industries are ready, and that's the part that I would argue, and that it's just a matter of connecting those two into a system that will work. I want to respectfully challenge that in a way where, because of the history of general purpose technology teaches us anything, it is that the technology is never what powers the industry. The system we build around it is actually what powers the industry. We can have a marvel of technology. It can be a drone, it can be a humanoid, it can be anything, but that's not the only powerhouse of the industry. I have an example that history teaches us, and driving here we had time to discuss a lot of topics, my colleague and I, and one of the topics was the train. And there is a great example. In the 1800s, the locomotive was actually this marvel of technology that humankind developed. The locomotive by itself, it didn't change a lot. It changed a very little. What changed the society is basically what came after. The standardization of gauges, the signaling system, the timetables that for the first time in history forced cities to basically align the times so they can plan ahead. The institutions grew around the iron industry, around the whole railroad industry. And then what we come up as a conclusion is that the train, the product, is the opportunity. But the rail network was actually the transformation. The more recently, we watched it happen again. Smartphones. Smartphone, again, it's a product that merely advanced the telephone. And by itself, it didn't change a lot. But what came after, the applications, the apps that we have on our mobile phone is actually what changed the way how we function, the society, and the way how we organize our life. And again, it required fundamental shift in how organizations understand its potential. It's not just about the product. The organizers of this Congress have named the current wave of that opportunity physical AI. It's a good name. And intelligence is leaving the data centers, and it's slowly progressing into a real physical world where we have now more and more examples where companies and policymakers are trying to understand how to use this intelligence in a way that is actually applicable. And because of that, I would argue to you today that drone technology finds itself in the basically same position as we saw the train, as we saw the smartphones, because the hardware exists. The specifications impress. Airframes are flying farther than we ever imagined, carry more than we ever imagined, and autopilots are getting more and more mature. Sensors are getting smaller, data links are resilient, and yet, and this is the uncomfortable truth for my industry mostly, is that the ability to turn the inventory into real-world impact is still lacking. The drones are ready, but the industries are not. And here, I want to offer basically a diagnosis that we at ORQA hold as a matter of conviction and not sort of a marketing. Most of the industry is focused on pushing specs alone, just make a better, more attractive product. And its goal is to deliver, of course, a better product, but it's not to engineer an outcome, to work on the boring stuff. The industry response to infrastructure gap has largely been to ignore it, producing point solutions for a systematic problem, and basically treats everything around the drone, the training, the implementation, the doctrine, the supply chain, as something, somebody else's problem. And this is the quiet reason so many drone programs, civilian and defense, stall between impressive demonstration and actually a repeatable deployment. Being ready to deploy to its full potential is the real challenge. We have many examples of great products, but deployment is the biggest challenge. So what does the infrastructure of transformation actually look like? Let me offer you 4, I would call them pillars, that I think generalize beyond my own industry, and basically we can, I think, discuss it in every industry that we discussed so far. The first one is the honest place of robotics that a couple of colleagues already mentioned, and that's, what one of the friendly companies in Croatia says: don't send a man to do a machine's job. We have a lot of examples where, robotics can actually do the missions or the tasks in the environment where, human is too expensive and too dangerous to send. This is the first, most obvious way of using advanced robotics, in this case, drones. The second pillar is, of course, artificial intelligence. And I want to be very careful about this, because conversation around AI often has a tendency to swallow every other topic in the room, and it's all about AI. And I think we are a little bit rushing ahead with these discussions while we don't have the railroads set it up. Artificial intelligence will have a key role, that's no question about it. But I would say primarily as a tool, as something that is supporting decision-making and system management rather than, standalone solution as a product for itself. AI belongs in the loop, augmenting the humans and the institutions that remain accountable. Our discipline is to keep AI in the proper place, to be powerful, pervasive, and bounded. The pioneers in the report that I read, that we had a chance to read before this, put it a little bit more bluntly than I would ever dare to, and they said that the physical AI deployed without adequate safeguards is like handing a chainsaw to a child. And although it's maybe a little bit dramatic, it serves a point. The third pillar is modularity, and that part is very critical for drones in particular, but I would say in any robotics. There are many reasons why. First of all, the ability for the same system to adapt to different purposes means that, if you build a platform for one mission, that platform will die with that mission. If you build a platform that is modular, that can serve multiple missions, it will survive this transition and it will be scalable. And scalability is one of the biggest challenges that we are facing now with, products that are innovative, that serve its purpose. The prototypes are great, they are, very exciting, but when you come to a point, okay, give me a 10,000 of something, we all stand and scratch our heads. And that's where we as a hardware company realize that modularity plays a big role in scalability. If you have a system that is modular, where you can build a component that can serve several platforms, that's where you get to the point where you can scale. And this is something that all companies in hardware business need to invest a lot. The fourth pillar is, of course, the last part, and that's the integration. And that's something that I'm looking forward to discuss with all of you here, is in various technologies into, combining them into functional wholes. That's the part that comes at the end when you have a modular, scalable platform. That's where the cooperation comes. That's where we in Europe, but also globally, bring solutions that actually play a vital role to end users. We have the hardware, we have the sensors are getting smaller, the platforms are getting more efficient. Now it's all about how we use that. And now, with all of those four pillars, the autonomy, the AI, modularity, integration, they all describe the engineering substrate of the next industrial wave. But a substrate is not an ecosystem. A substrate without an ecosystem is a technology demonstration, not an industry. It's a cool demo. And this is where I want to speak directly to you again. Europe has talked about technological independence for a long time. The strategies are written, the roadmaps are published, the summits are well attended, and there is a lot of, the number of working groups that I've met and I've discussed is amazing. But the strategies, the roadmaps, they are not independence. They do not guarantee independence. To achieve true technological sovereignty, Europe must go beyond strategies and align its entire ecosystem, linking innovation, production, and market demand into cohesive and responsive system. Innovation without production, production without demand, it doesn't serve its purpose. Research alone does not secure us. It's very important, but it does not secure us. Prototypes alone do not secure us. They're really important, but they do not secure us. And what secures us is the flow from laboratory. We saw the first great presentation from Dr. Kovac. From laboratory to factory, from factory to users, and then back from users to, again, spec sheets where we redefine the product, we redefine the solution, and bring something that actually plays a vital role. Ultimately, competitiveness will depend on the ability to act. Delivering industrial capabilities quickly, reliably, and at scale from within Europe's own industrial base. So not announced, not demonstrated, delivered. Quick demand and supply. This is where we prove ourselves, and this is where we actually talk about what is realistic and what is not. That is the benchmark, and it is not easy, it's demanding, but it is the benchmark that our competitors are being held against, and we should not settle for anything less. At ORQA, we operate under a different premise. We believe technology is only powerful as the infrastructure, of course. So we do not serve ourselves as a drone company. We don't look at ourselves as a drone company. Although we are one of the biggest producers of FPV drones at the moment, we look beyond that. We see ourselves as a transformation company, one that happens today to be 100% focused on FPV drones. But tomorrow, we already see extent of that same discipline into embodied AI, autonomy, and robotics at large. What this looks like in practice is a platform, call it ORQA X, that is vertically and horizontally integrated platform engineering the entire drone category, not just the airframe. It's the components, it's the drone system, manufacturing capabilities, sovereign supply chain, very important part. And then again, after that, is software developer programs, strategic partnership, and also a big part of the work is work with the end users, decision makers, policy makers, where we at the moment work together with them, and not only on products, not only on solutions, but also on application of those products. Each element, of course, is designed to work together as one. So the system becomes greater than any product we ever developed. It's all about bridging between inventory and impact, between specs on the sheet and the power to create effects in the real world. This model is not an easy model for a hardware company to talk about doctrine, implementation, use. We would all be a lot happier that we just talk about the drone and then you figure out yourself how you're gonna use it, or what is gonna be the use case, but that's not our reality. We need to take a step forward and cover all the gaps in the industry. We chose this model because we are, I would say, tech optimists who believe in the power of robotics and autonomy to radically advance human potential and society at large. And because we know firsthand that successful demonstration is not a guarantee of any successful project or any successful business. One successful demonstration does not guarantee anything if we don't have the entire ecosystem. And ORQA's founding premise is that you engineer outcome and not an object. So we do this from Croatia, inside of European industrial base, supplying our Western competitors and partners with components and helping them also develop solutions that serve their purpose. Not because it is convenient, but because sovereignty and at this moment in history is procurement policy, it's industrial strategy, it's moral posture all at once. We are in short, one company trying to lay the rails for our own locomotive. Europe has not yet finished building this system, and this is a part where we need to join forces. We cannot do it alone, and we do not pretend that we should. So what is the ask that we usually ask our partners, and I will ask you today as well. First, let us stop treating the drone or the humanoid or the robotaxi or surgical robot as the destination. They are carriers. The transformation is in what they enable. Our conversation at the policy, industrial, and capital level as well must move one layer up from the device to the system of devices that serve end users. Second one is let us treat modularity and integration as strategic imperatives, not engineering preferences. A continent that standardizes interfaces, insists on interoperability, and rewards open architecture will outproduce one that does not. And third, let us be unsentimental about AI. It is an accelerant, not a foundation. We will build autonomous industries on disciplined engineering, robust physics, and accountable systems, with AI threaded through them where it helps and restrained where it does not. The countries that chase AI as a slogan will buy their autonomy from another country. So let us take the ethical and human architecture of this wave as seriously as the technological one. If we want physical AI to lift societies rather than sort them, reskilling, education, and clear liability frameworks belong in the infrastructure plan, not in a footnote besides it. Rails without stations do not serve communities. So I will close here where I began, and I will close with a picture of what we at ORQA believe actually works. For most, a machine is simply a tool you can hold in your hands. For us, it's a completely different thing. For us, a machine is everything. Every inch of hardware, every component, every block of code, every fabrication cell, supply chain, but also it is every developer program, strategic partnership, doctrine change. We are not just about drone, but the world around it. That is what an infrastructure for us looks like. And this is something that, in the moment we accepted it, the good times for us began, but also the hard times. Collectively, all together, not only here, but as an entire continent, globally, as a Western a society, as an alliance, we need to do the same work. The autonomy is maturing, physical AI is here, hardware, as one of the colleagues said, is already at a very high level. And now in front of us is a harder, slower, and less glamorous work. The rails, the stations, the timetables, the supply chains, the standards, the training, which is a big part as well, because you're going to have a lot of pushback from the users. There's no point of the very advanced and cool product if the end user is not properly trained. If they're not prepared, they will push back. So tomorrow, it's going to be robotics. Today, for us, it's drones. But tomorrow, it's robotics and autonomy. And the underlying discipline is the same. So the approach needs to be the same. Transformative technologies do not become transformative on their own. They become transformative through the system and infrastructure we build around them. So if this Congress on the beautiful Lake Como is anything beyond this beautiful view, then let it be that we leave this Congress with the infrastructure and cooperation in our mind. Thank you.
Mislav, thank you so much.